All right, everybody. So today we are going to be covering two notes because they are really short. And so today's assignment, you will be getting a worksheet that has classwork 6.5 on it. And on the other side, you're also going to get homework 6.5, which is also just on that same worksheet. So you're going to be working off of the same worksheet for both. Just a reminder, when you're looking at this, it says page 18 through 19. Remember, that should be finished today, torn out very carefully, put your name on it, turn it in. And before you go today, you need to make sure you look at everything else as a page number. And if you still have them in your packet, well, you're supposed to put your name on it and turn it in. Tear it out very carefully and then turn it in. So make sure you write this in. Again, this worksheet will be coming to you shortly. We are going to be doing note 6.5 first, which will then give you time to do today's worksheet. So here we go. So let's turn to page number 19 first. So here's page 19. Let me give you a moment to catch up. So turn to page 19. All right, so this is one of the questions on your homework that needs to get turned in today. I did want to talk to you about it. Many of you left this one blank, possibly. So before you turn in page 18 and 19, let's either check your answer on this problem, or more importantly, let's just make sure that you get it done. If you hadn't done it, well, this is your chance to get it done with us. All right, so it says you deposit $200 in a savings account that earns you 3% interest. So the idea is, and it's compounded annually. So because it's going to happen just once a year annually, we actually get to use the formula that says y is equal to a 1 plus r to the power of t, because it only happens once a year, so we get to use this. Now remember, one of the biggest things in using this equation is knowing what the letters stand for. So I'm going to read the problem again, and we're going to try to figure out what letter it represents. So I'm going to deposit $200 in a savings account. All right, so we got our first number. But remember, that's what I'm starting my savings account with. Well, then that's your A value. Your A value is your initial amount. It's what you start with. Then there's another number involved here. They said 3%. Well, percentages, according to our notes from Monday, means it represents our R. That's our rate. So the R is 3%. But remember, we actually don't use percentages in our math problem. We need to turn that back to a decimal. And what we mentioned in class is, here's the decimal. You always move twice. So remember, we're actually going to use 0.03. That'll be the value that we use. All right, and just like anything else, what we mentioned in class was, it says write a function that represents the amount of money in the account after t years. So they want me to leave the letter t alone. All right, well, here's my equation. I only have two numbers available. Well, just like anything else, formulas and equations are meant for one thing: plug in what you can. So it says y, it says equals, there is an a, well, the a is 200, so let me write my 200. There's a parentheses, there's a 1, there's a plus, then it says your r, excuse me, it says your r is 0.03, so we plug that in, and then it says a power of t. Well, we're supposed to leave the t alone, so then there it is. There's one form of this equation already. But remember, we did mention it in class. If there's any math that you can do, you should do it. No, we can't distribute by 200 because there's a power of t, but I can definitely handle that inside part. So now my true equation is y is equal to 200, and then add up the yellow. 1 plus 0.03 is 1.03 with a power of t. And just like that, there's my equation. That's the answer for number 15A. So they wanted me to set one of these up. Now that part is done, well, we get to try one more time. They said, well, how much money is in the account after 4 years later? So that means that when I put the 200 in the account, right, I went to Chase or somewhere, put $200 in, and then I just left it there. Left it for 4 years. So I'm going to log into my phone. I'm going to see how much money is in there. This is why you created this equation. This is the equation for your money. So y is equal to 200, 1.03. And yes, there's a t up there. But remember, right where the t is, they said 4 years later. Well, then your t is equal to 4. Well, then toss that in there. And then, of course, you're not expected to be able to do this in your head. You can't freeze up on us. As soon as you see this, it's time for you to start getting your calculator ready. So we get our calculator going, and it says 200 parentheses 1.03. Give it the power button, and then a 4 for my power. Now, remember, we are talking money. You don't go to a restaurant and they say, you owe me $225.1. It makes no sense. When we're talking about money, my answer then is definitely the 225, but now we have to talk about cents. So you see there's 10 cents, or it's going to be 11. So it's either 10 or 11. Well, that's just a little one. Then we're sticking to 10 cents. That's how much money is going to be in my account when I log in. So there's my equation. And just so you know, if I wanted to find out how much money was in there 10 years later, I'm going to use the same equation. The only thing is, I'm going to put a 10 up there. So you do have one of these on today's classwork 9.5. So when you get your handout, you're going to do exactly what we did here for number 19. But anyways, the note that we were supposed to cover for this video, just wanted to throw that one in there, is on page 20. And again, if it's not numbered, number it yourself. So we're going to be doing notes 6.5, solving exponential equations. Now, one of the things you have to know is, well, how do I recognize an exponential equation? Well, just remember, if something is an exponential equation, it means it's going to have a power is, I should say, the power is a letter, a variable, right? When your power is a letter, that's how we know something is exponential. Remember, this is exponential. Like if I say stuff like 5 to the x, this one here is not exponential. When you say stuff like x to the 5, that means something completely different. See, this is what we're talking about. Exponentials have a power that's a letter. This is not an exponential function. Now, let's keep writing. This is just a one-page note here, so it should go by kind of quick. But it says, exponential equations are equations in which the variable occurs as the exponent. So it's exactly what we just mentioned. We said the power is a letter. The variable is the exponent. And like I said, here's a couple examples. We already mentioned 5 to the x. The power is a variable. Then we're good. That's an exponential. Even if it says 3, and even if the power is x plus 1, yeah, it's still a power. Look, they're not the same size, so it's still a power, still an exponential because there's an x up there. Even if it gets as weird as this. Let's say it says 7 to the power of 2. Now, that's not exponential, but if I do this to it, see, the fact that all of this is the power, that means this is an exponential function. Why? Because there's an x up there. That's what makes something an exponential function. So here's today's rule. The property of equality for exponential equations. Okay. So here's the idea. If it says, if 2 to the power of x is equal to 2 to the power of 5, then the question becomes, what is x then? Well, we have to understand a couple things, right? So let me bring in another little piece of paper here, just so I don't mess up the notes. See, here's what they're saying. They want them to be equal with each other. That's why there's an equal sign. This side says 2 to what power? This one says 2 to the 5. Well, this one right here, remember the meaning of 2 to the 5? That means 2 times 2 times 2 times 2. 1, 2, 3, 5 times. Well, now they're asking, well, how many 2's do I need over here? Well, if equality is supposed to exist, and I put 5 on this side, well, then I better put 5 over here too. That's the only way things can be equal, if they're exactly the same on either side. So if that's the case, if this side has 5 number 2's in it, well, when it says, well, what's the x going to be? Well, then your x has to be the number 5. That's the only way that the bases can continue to be equal. That's if the powers are equal. So there's the rule for today. If the bases are equal, so this is a base, this is a base. I'm not talking about powers. So the rule says, if the bases are equal, then, well, look at these things. These are the powers. They're not regular numbers or letters in this case, they're powers. Well, then the rule is, then the powers must be equal as well. If the bases are going to be equal, then the powers are equal. And that's the rule for the day. If the bases are equal, then I get to make the powers equal to each other. So let's put it into practice, right? Now, keep in mind, we're talking about powers, and it only works if the bases are equal. So let's start looking at the first example. See if we can keep that little note there. Yeah, we can still do it so we can see this and this. All right, so there's the rule for the day. So let's check it out. When I see that first problem down here at the bottom, letter A, example A, solve the equation. It has a base of 3, and it's got a base of 3. Great. They have the same base. That means I can use today's rule. Today's rule says equal bases, yes, then make the powers equal to each other. The powers are equal. So that means this entire power, yes, all of that is a power. The 1 is not the size of the 1, it's a power. And the 5, we get to set them equal to each other. That's it. And now you need to bring in all your skills that you've learned, that you've been using all year long. We had a lot of people freezing up on this and saying, well, what do I do next? You shouldn't be asking that question. You already know how to get letters by themselves. Just trust your skills. Subtract the 1, and then just like that, x is equal to 4, and look, we're done. Basic solving. Don't make the math tougher than it is. Now, this one gets a little interesting. Excuse me, a little interesting for a reason. See, the bases are the same. Check. Now I have to look at the powers. The power here is 2x minus 3. A little minus sign there. When you look at this one, you might say, but there's nothing there. There is. And no, it's not a 0. If it were 0, I wouldn't even write this down. Don't forget, we have an invisible power of 1. So let's zoom in a little bit more now. So we have an invisible power of 1. We already used the rule earlier. So then I'm going to put a 1 here, and that's my power. The rule says if your bases are equal, and they definitely are, they both say 6. I'm not going to use that 6 anymore. I get to use the rule. I'm going to make my powers equal to each other. And now I'm just going to solve the way we always did. Put my little line right through the equals. And then here we go. I am going to add a 3 because I'm trying to solve for x. Add the 3. We always get rid of adding and subtracting first. 4 is equal to 2x. And don't forget, the only way to get rid of this 2, they're right next to each other. Division is the only way to get rid of multiplication. And so we get x is equal to 2, and just like that, we're done. So if you notice, we're just going to practice our solving skills for this unit or for this lesson. All right, we have one more to try out here. See how this one goes. All right. It says a 10. Good. It says a 10. All right, well, that's all I needed to see. When they have the same base, then by force, the powers, which is all of this, don't leave anything out, the powers must be equal to each other. So 3x, that power, has to equal the 2x plus the 3. The powers are set equal to each other. And now I just solve. Now remember, you're solving for x. You have too many x's. And I don't want to bring the 3 this way. There's already too much going on over here. So that's why, just like we've learned, I'm going to get rid of the 2x. So I'm left with 1x, so just x. We don't write invisible ones. Equals, and I'm left with a 3. And look at that. I thought it was going to be tougher. We're already done with that problem. So again, the basic rule is, again, it only works though if they have the same base. Then I make my powers equal. This is how we solve exponentials. This is how we solve when x's are stuck in a power. So let's see. They don't take long. Let's do a little more practice. You're going to practice with your classwork anyways. All right, so I look carefully, and yes, I notice they have the same base. I can apply the rule then. If they are not the same, I would not be able to do this problem. So here's my power. There's the power. The rule is make your powers equal to each other because they have to be equal to each other. And then you solve. We already said the only way to get rid of a number that's next to a letter is, as always, to divide by that number. And so just like that, see, we're done. Don't overthink your solving. You've done it for a long time. Trust your skills. All right, let's see the one next to it. There's a base 5. There's a base 5. Hey, look at that. They match. That's what we want, which means if my bases are equal, then the powers, I like to circle them so I don't accidentally leave something out, then my powers better be equal to each other. This one says 2x. This one says x plus 1. All right, I've got too many x's. So I'm going to subtract the x. 2x minus x is just x. We don't need to write a 1. It's invisible. Over here, I'm left with the positive 1. So a 1, see, just like that, we're done. That's why we don't write invisible 1s in front, because then it looks like we still have more to do. We're done with that one. All right, so that brings us to the last one that we're going to practice with. And again, when you look at it, it has a 7. It has a 7. The bases match. And the rule is, if your bases match, then I'm going to make my powers, which is all of that, and all of that, not the 7s, I'm going to make my powers equal to each other. And then I'm going to bring every skill that you know when it comes to solving. So, again, don't move the 5 or the 1. Get your x's together first. Since this is the smaller amount, I'm going to move that x first. I'm going to subtract an x. All right, so I still have 2x plus 5 is equal to 1. All right, I got to keep it going. Subtract the 5 from both. Now, be aware that when you do your classwork today, you will have some answers that are fractions, and that's okay. I know today none of these ended up being a fraction, but if it's a fraction, that's nothing wrong with that. And again, the only way to get rid of a number next to a letter, to get rid of multiplication, we use division. And of course, that's what our fraction line is for. And a negative divided by a positive is a negative. So be careful with your powers. And just like that, we're done. So again, in order for us to apply the basic rule of the day, just make sure the bases match. If they do, make your powers equal to each other. Keep the math simple. Don't overthink it. All right, it's time for you to try that classwork. Make sure it says classwork, not homework. So do the classwork side. Work on that for a few minutes. And then we'll move on to the next set of notes.